What's up guys, Dylan here, and in this video I'm going to teach you all about linked lists and show you how to implement them in Python. So let's get into it. So on your screen right now you can see an example linked list. Now a linked list is just a series of nodes that are linked together. Now the way I've represented my nodes here, the top box represents that node's current location in memory, and then the bottom left box represents its data value, and here I've represented my data values as integers, but they can be any data type or object available to you in the language. And then the lower right hand box just contains the memory address of the next node in the list. So that is how the list is linked together. And then the very front node is referred to as the head node. So what type of methods do linked lists normally have available to them? Well, linked lists typically have an add method, which allows you to add a new node to the front of the list with a specified value. They have a remove method, which allows you to remove a node with a specified value. There's a search method, which allows you to search for a node, a size method, and a print method. So let's go ahead to implementing those in Python right now. So as you can see, I've opened up a linkedlist.py file in Sublime Text Editor, and I've already started to fill in my node class and my linked list class with the method stubs. So go ahead and take a moment to pause the video right now to fill those in your own editor so that you can follow along as I fill out the rest of these methods. So let's start with the node class. This node class is pretty simple. All we have to do is to write the constructor. So we are going to go ahead and allow the user to pass in a next node, originally set to none, and a value, originally set to none. And we want to originally set it to none just in case there is nothing there. So now let's create those class attributes by saying self.next is equal to next node, and self.value is equal to value. So that is it for our node class, and let's move on to our linked list class. So for the linked list constructor, we simply need to allow the user to pass in a reference to the head of the list. So we're just basically creating the head of the list if the first node is the first time the linked list is being created. So we're going to say head is equal to none, and then we could just create the head attribute of our linked list like so by setting it equal to head. So now let's go ahead and move on to the add method, and as I type in the code over here on the left, you will be able to see on the right hand side what is visually happening to each of the nodes in the list as we write our code. So let's go ahead and get into this. We are going to allow the user to pass in a value for the new node, and all we have to do is to declare a new node like so, and we will use the node constructor to give it a value of whatever value the user wanted. Now all we have to do is, because we're adding the new node to the front of the list, we are going to set its next node to our current head. And now all we need to do is update the node that the head is pointing to. So we just say self.head is equal to new node like so. And that is all we need to do for the add method. So for the remove method, we're going to allow the user to remove a specific value. So add that into the parameters. And the first thing we need to do is check if there are nodes in the list, because if the list is empty, we'll get an error. So we're just going to say check if list is empty. So we'll just say if self.head is none, so basically it hasn't been declared yet, then just exit the function. We don't want to do anything if the list is empty. So Now, the way that this removal is going to work, because we only have a reference to the next node and not the previous node, is instead of searching through the list and finding if the current node that we're looking at has the value, we need to look at the next node's value so we can get rid of it and link the node after that to the current node. If we tried to delete the current node, then we'd have no way to link the next node back to the previous node, which would ensure a continuous list. So we are going to find node with the value, and we need to create a temporary node called cur that is going to be equal to self.head, because if we tried moving through the list by changing self.head, we would lose all of the original nodes. So now let's just use a while loop while current dot next exists, so is not none, and we're just going to check. So say for the case that the node is found, then that means we'll have if current dot next is equal to value, then we'll basically just link the current node to the node after the next node to get rid of the middle node. So we'll say current dot next is equal to current dot next like so, and then we are all done with this method now because we have removed the node. So we'll say return. But what if it was not found? So if it was not found, we just need to move on to the next node. So we're going to say current is equal to current dot next, like so. So that's all good, but the method is still incomplete. Say for example, the value that we want to remove is on the head node. Well, we actually haven't checked the head node yet because we've only checked the first node that comes after the head node. So real quick, we'll just check the head node like so. So we're going to say if self.head.value is equal to value, then we are going to say self.head is equal to self.head.next, which will just get rid of the head node, and then we can return because we're all done. Alrighty guys, so now let's go ahead and move on to the search function. Now this one is actually pretty easy. All we really need to do is use our temporary current variable again and set it to self.head, and we'll traverse through with a while loop. So while current is not none, so basically we haven't reached the end of the list yet. We're going to check if current.value is equal, oh my bad, we're going to say if current.value is equal to value. This means that it is in the list, so we can return true because the value does exist within the list. And if we end up getting to the end of that while loop without ever returning true, that means that the value was not found and we reached the end of the list. So we will return false because the value is not in the list. Now size is pretty easy. We are just going to say current is equal to self.head again, and count is equal to 0. And then we can just say while current is not none, count plus equals 1 to increment, and we'll say current is equal to current.next, and at the very end return count. And now for printing, there are two different ways to print a linked list. One way will print each value on a separate line, and one way will print each value on the same line. So I will show you those two ways on your screen now. So on the left hand side, you have how to print each value on separate lines, and on the right hand side, you have how to print each value on the same line. Just pick whichever you prefer. Alrighty guys, so that does it for my Python linked list tutorial. If you want to see my next Python data structures video, click that button right there to watch the next one right now. And if you like this video, please drop a like and subscribe for more Python videos, and I will see you in the next video.